Hello Geometry, I'm back with a new video for you guys. This is going to continue our review of Chapter 3 from the first semester. It's going to look a little different than what we've done before in this remote learning, but there's going to be a lot of algebra in here as far as how do you write equations of lines and take those equations and graphing lines as well. So I'm just going to jump into it. Everything, by the way, is being done from the homework that's attached on Google Classroom. So the first skill I wanted to revisit was how do you write the equation of a line that passes through 2 points? And here's what we talked about last semester. The main components of writing an equation require you to find a relationship between y and x by finding the slope of the line that passes through these 2 points and finding the y-intercept, okay? So if you recall, our first step in this case is going to be finding m. M has a specific formula of taking the two y's and subtracting it. Remember, the y's represent the rise. So if you subtract them, you're taking the difference between the 2 points. That's how high you got to go up or down to get from one point to the next. And then you've got to do the run, subtract the x's. So m is slope, which is rise over run. y2 minus y1 over x2 minus x1. So here are your x's. X's are the left coordinate. Y's are the right coordinate. Y right, x left. It's kind of an easy way to remember it if you think about it with that same vowel sound. So then y2 is going to be 1 minus 6 over 7 minus, no, it's 7 minus negative 3, not 7 minus 3. 7 minus from the formula, negative 3 is my x1. So don't get caught with that. Sometimes people will just do 7 minus 3, and it will not be correct. So 1 minus 6 is negative 5. 7 minus negative 3 is the same as 7 plus 3, which is 10. So you got negative a half. And that's our first part. We want the slope. We got it. Part 2, find the y-intercept, also known as the b-value. We figure that out by using sort of like a template equation. Like here's the template for most equations of lines that you can write. We know what m is, and we can actually use an x and a y because look, when x equals negative 3, y equals 6. When x equals negative 3, we know y has to equal 6, and in this relationship, the m is equal to negative a half. Now we could have said let x equal 7 and y equals 1, but I'm just going to use the first point. So 6 goes in for y. Negative a half goes in for m. X equals negative 3. Remember, this is multiplication here. And then the plus b, that's the thing that we're looking for. B equals what? So then 6 is equal to negative times a negative is positive. What's a half of 3? Half times 3? It's 1.5, or 1.5. And then to get b by itself, you subtract the 1.5 from both sides. So these cancel out. B is by itself. 6 minus 1 is 5, but you have to take a half more out. So that's 4.5. All right. So we've got the two main components of what makes a linear equation work. If y equals mx plus b is the template for the equation of a line, then you just plug in for m and for b. Remember, the template requires you to have a y and an x as placeholders. So don't think like, oh, let's plug in 7 and 1 now for the x and the y. It is what it is, and it's done. Let's skip forward. All right, I am right now focusing on number 10, number 11, number 12, and 13. This problem really encapsulates, it summarizes, it does everything we need to know about writing equations for parallel and perpendicular lines. So we're given y equals negative 3x minus 2. First things first, can we graph this? And my answer is, I hope so, because we know what the template is for a linear equation. There's the template. The template tells us that the b value is the y-intercept, which is negative 2, which means it crosses the y-axis, there's my x, at 2 units below the origin. That's what this negative 2 implies right here. This negative 3 represents the slope. Now, we probably should talk about it in terms of a rise over a run. So if you're given just a whole number here, you should always just put it over 1 to make it a fraction. So what we do is we say from the point we just plotted, go down 1, 2, 3. Negative means vertically going down, over 1, like that. You can also go plus 3 over negative 1, because that's the same value. You can get negative 3 by taking a negative 3 divided by 1, or you can get negative 3 by taking positive 3 divided by negative 1. So go up 1, 2, 3, left 1. Up 1, 2, 3, left 1. Up 1, 2, 3, left 1. And that's pretty standard for a line. If you've got a ruler, I would encourage you to use one. So this line is number 10. Again, pretty basic stuff I think you guys already knew how to do. The second thing is graph the line parallel to it that passes through 2, negative 3. Now that's a little trickier. So what we're going to do is first talk about the point that it crosses is 2, negative 3. So x left, y right. So the x-coordinate's 2. You're going to go right 2. The y-coordinate's negative 3. You're going to go down 3. So right 2, down 1, 2, 3. So what's special about parallel lines? Parallel lines never intersect their originals. So if y equals negative 3x minus 2, then y parallel, and I'm just using the little double line symbol to imply parallel. It's kind of standard. You guys saw this earlier this year. It equals a line that would never cross negative 3x minus 2. Now here's the thing. We talked about how the slope of parallel lines, the slopes of parallel lines, they have to be the same. So for my y parallel, I know that negative 3 has to be the number in front of its x value. I don't know what b is at this point. But because I've already plotted a point, I can use the slope plotted from that point to get other points on the graph. And if all I'm asking you guys to do is graph the line parallel to it on number 11, then what you do is you say, from the point I plotted, I can go down 1, 2, 3, right 1, because parallel lines have the same slope. Or I can go up 3, left 1, up 3, left 1, up 3, left 1. And there's number 11. How about 12? We're talking perpendicular. So I'm going to just start with 1, 5. That's the point that it goes through. Over 1, up 1, 2, 3, 4, 5. It's perpendicular to my original line, which I think sometimes students, when they don't have a good memory, especially with all things math, they say parallel lines don't intersect. Perpendicular lines do intersect. Well, that's true, but it's neglecting a very important part of what it means to be perpendicular. Perpendicular lines meet at a 90-degree angle. Okay? And the symbol is like this. It's an upside down T. Sorry. And there's an interesting relationship between the original line and its in a line perpendicular to it. And it's through the slope. The slope is called the negative reciprocal of the original. All right? So let me try to break that down for you. If m is equal to negative 3 over 1, then that means m parallel also equals negative 3 over 1. But m perpendicular is the flip of it and the negative of it. So what happens when I make 1 over negative 3 negative? It makes it positive. So I've got a slope of 1/3 now, which means I go from that point up 1, right 1, 2, 3. Up 1, right 1, 2, 3. Or down 1, left 1, 2, 3. Down 1, left 1, 2, 3. And as you can see, it creates a 90-degree angle right there. Okay. We got through 10, 11, and 12. Now, what's it mean to write the equations of those lines that I just graphed? Well, technically, they both should look like this. Right? They're just going to have different b values and different m values. Now, the first one's actually, we almost had it. Y parallel had negative 3x plus b. And the b is the place where it crosses the y-axis. I think I know where it crossed the y-axis. I've got a point for number 11, the parallel line at exactly 1, 2, 3 units above the x-axis. It's plus 3. The b value is plus 3. Now, I don't know, it's not so clear with the perpendicular line, right? I don't know if it's 2/3, 3/4, 0.8, 0.6, I don't know what it is. But here's what you can do. You can say, I've got m. M was 1/3. I've got x. We know it went through 1/5. I've got y. We know it went through 1/5. I can find the b value using the algebra that I did on the very first example we had. So, 5 equals 1/3 times 1 plus b. So 1/3 times 1 is just 1/3. And then I got to get b by itself, so I'm just going to subtract the 1/3 from both sides. And then b is going to be 4 2/3. If you take 1/3 away from 5, you get 4 2/3. So here's my equation of my line. Y perpendicular equals, my m was 1/3, x plus 4 2/3. All right, I'm going to make a second video on this same assignment to kind of clear up some other things, so I'll see you in a little bit.